In order to move forward with molecular geometry, we need to be able to draw the molecular shapes in the correct way. The way I'm going to show you now is not the exact perfect drawings of how the molecules look, but they will serve our purposes for what we need in the future. The VSEPR theory talks about how atoms will form a shape where they are as far away from one another as physically possible, because remember, all of these atoms that are in the molecules have electrons around them, and they will all repel each other so that they are as far away from each other as possible. I'm going to go through 9 major shapes that you will see in different molecules. The first one is linear. You'll notice that I'm only going to be talking about the central atom when I talk about how many bonds and how many lone pairs come off. Here's a perfect example of a linear molecule. The X, the central atom, only has 2 bonds and 0 lone pairs. Its bond angle is 180 degrees. The next type of molecular shape is trigonal planar, or like a flat triangle. You'll notice that there are 3 bonds coming off the central atom and no lone pairs. The next one is tetrahedral. It has 4 bonds and 0 lone pairs coming off the central atom. Now the reason why we draw it like this is it actually has a tripod down at the bottom with 1 terminal atom sticking off the top. That's why the oxygen at the lower part is a little smaller than the rest. It's actually behind the screen. Trigonal bipyramidal is like a flat triangle with a linear through it. Notice it has 5 bonds and 0 lone pairs. The O you see at the bottom right is actually behind the page, and the O you see in the bottom left is coming out of the page. An octahedral molecular shape has 6 bonds coming off of the central atom and 0 lone pairs. What you can't see here is that the O's that are on the diagonals are actually going into the page and out of the page as a flat square. Here is our first molecular shape with a lone pair coming off the central atom. Notice the lone pair coming off the central atom pushes the other atoms away so that they face down. This is like a tripod without the camera sticking up. Notice it's based off the same molecular geometry as tetrahedral, which you can see in the box up above, but instead of an atom coming off the top, there's a lone pair. And the angles are bent a little further down than what's in a tetrahedral because the lone pair pushes them down more than another atom. Here is a bent molecule with 2 bonds and 2 lone pairs. It's also based off a tetrahedral geometry. The 2 atoms are facing down, and the lone pair, one goes up above the page and the other one goes back behind. It's hard to see it here, but for our purposes in the future, this will serve its purpose. Square pyramidal with 5 bonds and 1 lone pair is based off of octahedral geometry. You'll notice that off the bottom, instead of an atom coming off, we have a lone pair, and it pushes the other 2 up away from it. Square planar is also based off of octahedral geometry. It has 4 bonds and 2 lone pairs, and you'll notice that instead of bonds coming off the top and bottom, we have a lone pair on each side. When you draw your molecules, keep these in mind. Draw the molecule out, see what the central atom has coming off of it, and then rearrange the drawing so that it looks the same as these drawings.